Hello students. Hello students. speed and comprehension. Please remember, it's not a race. You need to understand a topic and get a command over that before you jump on to the next topic. Draw graphs and diagrams. This would help you if there is graphs and diagrams involved, and draw it so that you can understand how it's affecting the entire scenario. This would help you in broadening your vision and getting to the answers in a very less amount of time. And by far the most important aspect, that is try to solve before I solve, or at least give a real shot at the question. This would up your thinking capacity and shooting arsenal skills. Have a command over this topic. Follow the courses regularly. And last, practice the question. The more you practice, the better you are at every aspect. Next. That's the definition. Have a command over this topic. Follow the courses regularly. And last, practice the question. The more you practice, the better you are at every aspect. That's the definition. Alright. So that's a definition of a sequence. A succession of a term formed according to some rule or law is called a sequence. That is, let's say 1, 4, 9, 16 and 25. There must be some rule by which this sequence has been formed. So if we notice each term, we can see that that's a definition of a sequence. There must be a rule which is governing any sequence. For example, for this aspect, -1, 1, -1, 1. That is, let's say every alternate term is multiplied by minus. So we have it's governed by a rule that every alternate term, every next term is multiplied by minus. That's how we got the sequence. A finite sequence has a finite, that is limited number of terms. As explained in the very first example, we have 1, 4, 9, 16, 20. We have only 5 terms. However, an infinite sequence has unlimited number of terms. That is, there is no last term. As in the second and third example, we can see this sequence can go till infinity. The same goes for this, x by 1 factorial, x squared by 2 factorial, x to the power 3 by 3 factorial. This list also can go till infinity. Also, what is a series? Well, an indicated sum of the terms of a sequence. That is, in case of a finite sequence, a1, a2 and a3, that is the succession of the terms. When we add all the sum of the given terms, that is a1 plus a2 plus a3, we have a series. This series has a finite or limited number of terms, then it's called a finite series. In case of a finite sequence, a1, a2 and a3, that is the succession of the terms. When we add all the sum, so what's the pattern for 1, 4, 9, 16 and 25? We can have 1 and 4. The difference is finite. Between 4 and 9, there is a difference. Series is 5. Between 9 and 16, the difference is 7. Between 16 and 25, the difference is 9. So we can see there is a rule by which the sequence has been created. We can have 1 and 4. Next. Between 4 and 9, so this is a sequence. And for this sequence, that is, there must be some rule, and this is the nth term, in which it can be defined for the law 2n plus 5. Now we need to write the first term in each of the following sequence defined by this rule. So before I begin to explain for this sequence, I would like you guys to give a shot for this particular question, in which an is equal to 2n plus 5, and you need to find the first 3 terms for this sequence, each of the following rules. So before, you can put your answers in the chat box. I would like you guys to give a shot for this particular question, in which an is equal to 2n plus 5, and you need to find the first an is equal to 2n plus 5. Under this topic, we can see for n equal to 1, an is 7. It's 7. For n equals to 2, we have an equals to 9. For n equals to 3, we have an equals to 11. So that's the sequence which we got. We have 7, we have 9, and then the third term is 11. That's the third term. That's the first 3 terms of this particular sequence. Now, what should be the sequence for this particular question? Where an is equal to n minus 3 by 4. So, for n equal to 1, we have or in terms minus 2 by 4. That's the very first sequence when we put n equal to 1. Now, for n equal to 2, we have minus 1 by 4. That's the second term. For n equal to 3, we have an equals to 0. So that's how we got the first 3 terms in each of the following sequence defined by the following. These are the nth term, and when we insert n equals to 1, we got the anth term as 2 into 1 plus 5, it's 7. When we insert n equals to 2, we got 2 into 2 is 4 plus 5, that's 9. That's the second term. And for the third, and when n is equal to 3, we have 2 into 3, 6 plus 5, that's 11. So that's how we got the 3 terms for the sequence where an is defined by 2n plus 5. Next. So here we have a very interesting sequence called Fibonacci sequence. Fibonacci sequence is an arrangement of numbers in which we have no visible pattern. We cannot identify what has been happening to create this pattern. However, but the sequence is generated by a recurrence relation. That is, every next term is the sum of the preceding 2 terms. For example, a3, that is the third term, is the sum of the preceding 2 terms, a1 plus a2. The similar analogy can be applied for the a4, that is a4 is going to be the sum of a3 plus a2. That's the Fibonacci fourth. That's how we'll get the fourth term in the Fibonacci sequence. It would be equal to a3 plus a2. Let's see how we can get a3 plus a2. So the fourth term is going to be, this is the first term, this is the second term, this is the third term. The third term is going to be the sum of the last 2 terms. So 1 plus 1 is 2. Next, the next term is going to be the sum of the last 2 terms. That is, the fourth term is going to be the sum of a3 plus a2, that is 3. Next, the sum of these 2 terms is going to be the next term, it's called 5. Sum of a3 plus a2, that is 3. Next, the sum of these 2 terms is going to be the next term, it's called 5. Next, we'll discuss what's the 12th and 15th term in the Fibonacci sequence. Well, we have first as this, second as this, third as this, fourth next. So 8, 12 is going to be the sum of is going to be the next term. This is called 5. This is the first term. This is the second term. This is the third term. This is the fourth term. This is the
Next.
fifth term. This is the sixth term. This is the
Next
seventh.
we'll discuss
This is the
what's the 12th and 15th term in the Fibonacci
and
sequence.
the ninth term is
We
going
have
to be the
sum
sum
of
first and
E3, the second, that is
third is the
3.
fourth.
Next,
E12 is going
the
to
sum
be
of
the
these two
sum
terms is going to be the next term. This is called
the
first term.
tenth
This is the
term.
second term.
This is going to be
Third
this is the fourth term.
65.
Fifth
Next,
term. That 11th term is going to be 109. And the
this is the
12th
sixth term.
This is the
Next,
seventh.
we'll discuss
This is the
what's the 12th and 15th
is going to
term
be
in the
1
Fibonacci
and the
sequence.
ninth term is
We
going to
have
be
the sum of E3, the second, that is
That's how we'll
3.
do
Next,
the 12th term.
sum of these two terms is going to be the next
Going to
term.
be
This
the
is called
the
51st term.
10th in the Fibonacci sequence.
Going to be this is the fourth term, 65. Next,
Term. That 11th term is going to be 109. And the
this is
12th
the sixth
term.
term.
This is the
Next, we'll
seventh.
discuss what's the 12th and sequence.
The ninth term.
We have
Under the
sum of
sequence and
E3,
series
the
chapter.
second, that is
That's how we'll
3.
Under the sequence and series chapter, we need to find the first 5 terms in each of the expressions of the sequences in exercise 1 to 6, whose nth terms are where an is equal to n into n plus 2. Let's begin with the very first term, where an is equal to n plus 2. When n is equal to 1, for this particular exercise, when n is equal to 1, we have an is equal to 1 into 1 plus 2 is 3. When n is equal to 2, we have 2 into 2 plus 2 is 4, 4 into 2 is 8. When n is equal to 3, when n is equal to 3, we have 3 into 3 plus 2 is 5, 5 into 3 is 15. When n is equal to 4, we have 4 plus 2 is 6, 6 plus 6 into 4 is 24. And when n is equal to 5, we have 5 into 7, that's 35. So that's how we got when the first 5 terms of the sequence when an is equal to n into n plus 2. Next, we have when an is equal to n by n plus 1. Similar analogy, we'll write 1, 2, 3, 4 and 5. Math is all about the problems that you can solve. So for n is equal to 1, we have an is equal to 1 by 2. For n is equal to 2, we have an, the second term is equal to 2 by 3. For n is equal to 3, we have the third term is equal to 3 by 4. For n equals to 4, we have the fourth term as 4 by 5. And for n is equal to 5, we have the fifth term is equal to 5 by 6. So that's how we'll get an, all the first 5 terms of each of the sequence in when an is equal to n by n plus 1. Now let's find for the third question, that is when an is equal to 2 to the power n. For n is equal to 2 to the power n, we have the very first term as 2 to the power 1, that is 2. Second term we have 2 to the power 2, that's 4. Then we have 2 to the power 3, that's 8. The fourth term is 2 to the power 4, that's 16. And then We have 2 to the power, that's 32. Let's find the next 5 terms for an is equal to 2n minus 3 by 6. Here, 1 for the when an is equal to 1, we have 2 into 1 is 2 minus 3 is minus 1 by 6. For n is equal to 2, we have 2 into 2 is 4, 4 minus 3 is 1 by 6. For n is equal to 3, we have 3 into 2 is 6, 6 minus 3 is 3, 3 by 6 is 1 by 2, or we can say 3 by 6. Next, when n is equal to 4, we have 4 into 2 is 8, 8 minus 3 is 5 by 6. We can see there is a different pattern coming up in every sequence. That is, every next term in the numerator, we are adding it by 2 for the n of 4th. Now next find the 5th term in this sequence. That's going to be 7 by 6. So that's how we can find all the first 5 terms in each of the sequence in the given figures. Let's move on. The other questions are part of the problem. Please solve them and have them ready. And if you have any doubt, just get back to me or comment on the text, and then I'll revert back. Now, over here, we need to find the first 5 terms in each of the sequence in exercises 11 to 13 and obtain the corresponding series where a1 is equal to 3, an is equal to 3, 8, n minus 1 plus 2 for all n greater than 1. Let's begin this exercise. So we have a1 is equal to 3, so a2 should be 3a1 plus 2. That is, and a1 is equal to 3, we have 3 into 3 is 9, 9 plus 2 is 11. So we have a2 is equal to 11. Similarly, if we try to find a3, we can say a3 is going to be 3a2 plus 2. It's going to be 3 into 11, that's 33. 33 plus 2 is 35. So that's how we'll find the third term in the sequence of this particular series. Next, let's find the fourth term for a4. a4 is going to be 3a3 plus 2. It's going to be 35 into 3. The a3 is we have 35. 35 into 3 is 105. 105 plus 2 is 107. There we have it, the a4th term. Next, we'll begin with a5. a5 is going to be 3a4 plus 2. So we have a4 is equal to 107. 107 into 3 is 321. 321 plus 2 is going to be 323. So that's how we'll get all the first 5 terms of the sequence of this particular question. We have a1 is equal to 3, a2 is equal to 11, a3 is equal to 35, a4 we have 107, and a5 is 323. By this methodology, we can find all the first 5 terms in each of the sequence for any question that has been given here. Let's do the same for this particular question. Here we have a1 is equal to 1 and a2 is equal to a1 by the nth term. For example, a2 is going to be a1 by 2. a1 by 2, that's going to be minus half. Next, let's find a3. a3 is going to be a2 by 3. It's going to be a2 we have minus half by 3, it's going to be minus 1 by 6. Next, let's find a4. a4 is going to be a3 by 4. It's going to be minus 1 by 24. Do verify your answers whether you're reaching the correct answer or not. Over here, accuracy matters a lot. Next, a5. We have a5 as a4 by 5. It's going to be minus 1 by 120. That's correct. So these are the first 5 terms in the sequence where a1 is equal to minus 1 and the nth term is given as an minus 1, that is one less term by the nth term. So here we have a2 is equal to a1 by 2. That's a2. a2 is minus half. Next we have a3 as minus 1 by 6. Next a4 we have minus 1 by 24. And the last and the fifth term we have minus 1 by 120. The other terms in the sequence exercise can be found by using the same pattern and ideology, utilizing inserting the nth term in the given sequence to reach the respective answer. Let's move on to the next slide. So in this particular topic, we need to find the number of terms between the two numbers in a and b, in which we need to include a and b. For example, let's say the numbers are 5 and 11. So how many terms are there in between 5 and 11, including 5 and 11? So given the numbers are 5, 6, 7, 8, 9, 10 and 11. If we count all of them, it comes as 1, 2, 3, 4, 5, 6, 7. We have a total of 7 numbers including in between 5 and 11, including 5 and 11. So what would be the answer if we say that a is going to be 21 and b is going to be 87? So how would you find the total number of numbers including 21 and 87? Well, when the numbers are really small, it's very easy to count the given numbers. However, when the difference between the numbers is so large that it cannot be counted on figures, it would be really tough to calculate the total numbers. Thus, we came up with a plan. Any guesses? Any guesses? How many numbers should be in between 21 and 87, including 21 and 87? Well, that's the formula. When we need to calculate the total number of terms between a and b, including a and b, the formula is the larger number minus subtract the smaller number from the larger number and add 1 to it. For example, the total numbers including 21 and 87 is going to be 87 minus 21 plus 1 is going to be 67. That is the total of 67 numbers in between 21 and 87, including 21 as well as 87. We can apply the same logic for this particular question, in which we need to calculate how many numbers are in between 5 and 11, including 5 and 11. Let's see, 11 minus 5 plus 1. So 11 minus 5 is 6, and 6 plus 1 is 7. So yes, that's how we get the number of terms between two numbers, including those two given numbers. Let's go to the next slide. Well, what would be the, let's calculate the number of terms between two numbers. Now we need to exclude a and b. For example, let's say a and b are 5 and 11. Now, if we exclude 5 and 11, we have 6, 7, 8, 9 and 10. That is, we have a total of 5 numbers. We have a total of 5 numbers. Now, what should be the numbers in between 21 and 87 when we need to exclude 21 and 87? Well, the calculation would be quite tedious. Thus, we came up with another formula called b minus a minus 1, in which we need to subtract the smaller number from the larger number and then deduct 1 from it. That is, the larger number is 87, the smaller number is 21. We'll say 87 minus 21, and since we need to exclude, we need to deduct. That is, 87 minus 21 minus 1 is 66. Now, let's apply this logic for these given set of numbers 5 and 11. So 11 minus 5 minus 1. 11 minus 5 is 6, and 6 minus 1 is 5. So here we have it. The total number of terms between the two numbers, excluding those two numbers, the formula is b minus a minus 1. So that's a summary of how to find the number of terms between two numbers a and b, including a and b. Let's say a and b are 5 and 11. So the total, thus the numbers are 5, 6, 7, 8, 9, 10 and 11. But there are total 7 numbers, including those numbers. The formula for this particular math is b minus a plus 1. B is the bigger number, a is the smaller number, and then we need to add 1 to this. Now, the number of terms between two numbers a and b, excluding a and b, that is, we don't need to include a and b. Let's say a and b are 5 and 11. Thus, the numbers are 6, 7, 8, 9 and 10. So, total we have only 5 numbers. The formula for this value is going to be a bigger number minus a smaller number minus 1. That's how we'll reach the number of terms between the two numbers a and B excluding A and B. So how do we remember this particular logic? Well, whenever for both these two formulas we have B minus A common. The only difference is we need to add plus 1 in one case and we need to deduct 1 in one case. So whenever there is a case of including, that is, whenever we need to include the two ends A and B, then we need to add plus 1. Do remember, it's not plus 2, it's plus 1. The bigger number minus the smaller number plus 1. And when we need to exclude A and B, to find the number of terms between the two numbers A and B, we need to deduct 1 from the given figure of B minus A. So whenever there is a case of including, including means add and excluding means subtract. That's how we'll remember this entire sequence to find the number of terms between the two given numbers. Next, well, here's a mathematical journey of Carl Gauss and the sum of an arithmetic series. He came up with a plan. He was a brilliant mathematician, and his teacher was Carl Gauss. His teacher was really fed up, and he wanted to give him a tough problem because he was able to solve questions very easily. So they came up. He asked him to give the sum of 1 plus 2 plus 3 till 100. And the teacher was really happy, thinking that he has aced it, that he'll be occupied with this sum. Here we have a sum of the series of the first 100 natural numbers. So Carl Gauss, he was quite witty and sharp. He came up with a plan. What did he do is, he did a reverse. That is, he wrote 100 plus 99 plus 1. He added both the lines, both the figures given on the lines, and he got 101 for each of the figures. That is, 100 plus 1 is 100, 99 plus 2 is 101, and in total he had. Now we need to find the number. Let's have the number of terms in between 100 and 1. So if we want to include 101, we have 100 minus 1 plus 1, that is the number of terms. It's going to be 100. So we have total 100 terms, but since we have clubbed both of them, so it's going to be 2Sn. Since we have added both these two factors, it's going to be 101 till 101 multiplied by 100, because we have 100 such terms. However, we need to find only Sn, that is sum of the first natural number. 2Sn is going to be 101 100 times, so Sn is going to be Sn is going to be 101 into 100 by 2. It's going to be 5050. So that's the ideology he came up with. So people were really perplexed at how did Gauss found the answer so fast. What did he see that his teacher didn't? The answer is really simple. It's all about pattern recognition. He looked at the problem in a fashion where no one thought of. Now he added, if he tried to add, it would take forever. He couldn't simply complete, but we don't really need to add it all up by hand. Let's look at the series from each the way we did just right now. We add 1 plus 100, it's 101. We add 2 plus 99, we have 101. We have 3 plus 98, we have 101. We have 4 plus 97, we have 100. So on and so forth till the middle, that is 50 plus 51, we have 101. So we have a total of 50 pairs. Each of one adds up to 101. Since all of our chunks are same, of the same size, we can take a shortcut and simply multiply the size of the pair 101 by the number of pairs, that is 50, which is really easy to do since it's 100 into 50 plus 1 into 50. It's 5000 plus 50, thus we reach 5050. That's how Carl Gauss reached, and he came up with a plan with an idea which we use called sum of an arithmetic series. So this is the entire journey of how Carl Gauss came up with a plan of sum of an arithmetic series. So that's the summary. So by a sequence, an arrangement of number in definite order, that is, a sequence is defined as an arrangement of numbers in a definite order according to a given rule. It can be any rule. There can be a difference of there can be a difference of 2 in between the respective numbers. For example, 1, 3, 5, 7, 9 and 11. It could be this, or it can be a multiplication of 1 of minus 1 in between the given numbers, such as 1 minus 1, 1 minus 1. So that's a sequence. It can also be another sequence in which arrangement has been done in a definite order and it governs with a certain rule. We also define a sequence as a function whose domain is a set of natural numbers or some subsets of the type 1, 2, 3 till the kth term. Now, a sequence containing a finite number of terms is called a finite sequence, and a sequence is called infinite if it is not a finite sequence. For example, 1, 3, 5, 7, 9. Here we have only 5 terms. But what if the list can keep on going till infinity? Then this particular sequence would become an infinite sequence. Now, let's move for what's series. When A1, A2 and A3, that is the first, second and third term in a sequence, are expressed as a sum, that is when we add all the respective terms in the given sequence, such as A1 plus A2 plus A3, it's called a series. A series is called a finite series if it has got a finite number of terms. For example, let's say we have a sequence called 1, 3, 5, 7 and 9. Here we know that this sequence contains only 5 terms and thus it's a finite sequence. Now what would happen if we need to find the series of these given 5 terms? We need to simply add all the given terms, that is 1 plus 3 plus 5 plus 7 plus 9. It's going to be 25. So that's how we got the series of this particular sequence. Here we have arithmetic progression, and I'll be discussing all these intricate details when I'm going to take this particular chapter. In the upcoming class. So I have some last minute tips to maximize the score. That is, take notes of important formulae. It would be really helpful if you take the notes of important formulae because they are ubiquitously used all across the domains. Next, do a regular practice of the numericals. This would help you tremendously when you're trying to ace this particular topic. Next, ensure that every doubt, no matter how trivial it is, every doubt is cleared, even if it's the dumbest, because there is no such thing called a dumb doubt. Every doubt is as important to ace this particular section. Next, have a planned timetable. When you have a planned timetable, you can reach that 90th percentile easily. Next, do not follow and solve more number books. I'll say that doing so creates only chaos. Rather, choose an authentic and credible book and solve it thoroughly, or simply come online and have lectures from us, and then we can have as many discussions as possible. Also, do not compare a journey from others because everyone has its own speed and comprehension capacity. Also, make sure that you regulate the entire study hours so that you can maximize the score and reach that 90th percentile figure. Next, we are come on Unacademy. We have, and you can learn from the India's top CBSE educators. You can use the referral code as Anurag10 and join us. We have a course running for CBSE throughout the year. We are recently launching the course on sequence and series. That's me. I've scored 99.99 12th percentile in the AAA exam. I have 3 years of teaching experience and I have a graduation from BIT Mishra. I have came up with 2 lectures called course on sequence and series. In this course, I'll be covering sequence and series and all the details such as arithmetic progression and governing topics, all such as arithmetic mean, some of the terms, some of the important terms, some of the special terms such as some of the first and odd terms, some of the first even terms. Next, I'll be discussing geometric progression and the relevant governing topics. Next, I'll also be discussing harmonic progression and the governing topics as well. Also, in between all these classes, we'll also be having doubt clearing sessions so that this entire sequence and series topic of CBSE class 11 is so thorough and vivid in your structure so that you don't feel any hiccups when you're solving those questions in exam. Next, I'll also be conducting a mega quiz for only this particular topic, covering a range of easy, medium, difficult and super difficult questions from a pool of last 20 years questions so that you don't feel any hinge and any hiccups when you're trying to ace and command this particular topic. So let's do a walkover of what we just learned. So we have sequence and series, and sequence and series comes under the algebra section, which holds 37 marks amongst the total marks of 100. That's a usual course structure. Usually the template revolves around this aspect. So here we discuss the student strategy, what needs to be done, that is revise what has been done, take notes, pause the video according to speed and comprehension. Please remember, it's not a race. You need to ace the topic and then only move to the next section. Draw graphs or diagrams when required. And that's by far the most fundamental aspect. Try to solve before I solve, or at least give a real shot at a question. This would help you tremendously in upping up your arsenal and increasing your skill sets to tackle any questions under sequence and series. Next, follow the courses regularly. Also practice the questions. I cannot emphasize it enough. The more you practice, the better you'll get in this particular section. Next, we have a definition of sequence, that is a succession of terms, that is A1, A2, A3 and 4, that is the first term, second term, third term and fourth term, formed according to some rule or law. we have 1, 4, 9, 16, 25, we have minus 1, 1, minus 1, 1, and so on. So a finite sequence has a finite number of terms, which is given in the very first example, example 1. An infinite sequence has an unlimited number of terms, that is over here. That is, there is no last term. It's given in the second and third examples. Also, a series, that is, series is an indicated sum of terms of the sequence, that is, it's simply addition of all these given terms. So in case of a finite sequence such as a1, a2, a3 till an, the corresponding series is going to be the sum of a1 plus a2 plus a3 till the last term, that is an, where we can write it summation ak, where k starts from 1 and goes till n. This series has finite number or limited number of terms, and it's also called a finite series. So here we can find the pattern of how we have done. In between 1 and 4 we have the difference of 3. In between 4 and 9 we have a difference of 5. So we have a difference of 3, we have a difference of 5, we have a difference of 7, we have a difference of 9. So I think we can get the pattern that every next term is going to be the plus 2 term of the given difference. So here we wrote the first 3 terms in each of the following sequence, such as when n is 1 we have the first term as 7, when n is 2 we have the second term as 9, when n is 3 we have the third term as 11. Next, when n is 1 we have minus 2 by 4, when n is 2 we have minus 1 by 4, when n is 3 we have the third term as 0. So this is the Fibonacci sequence. In some arrangements we have no visible pattern. However, the sequence is generated by a recurrence relation, that is, the next term is the sum of the last 2 terms where n is greater than 2. For example, a4 is going to be a3 plus a2. Similarly, a5 is going to be a4 plus a3. Similarly, a6 is going to be a5 plus a4. Next, so here we try to find the 12th term and the 15th term in the Fibonacci sequence. We have first, second, third, fourth, fifth, sixth, seventh, eighth, and ninth is 44. 10th, the sum of 10 and 65. 11th is 109. 12th is 174. Next, over here we try to find the first 5 terms in each of the sequence where an is given as 2 to the power n. For the first term we have, for the first term we have, for n is equal to 1 we have the first term as 2. For n is equal to 2 we have an is equal to 4. For n is equal to 3 we have an is equal to 8. For n is equal to 4 we have fourth term as 16. For n is equal to 5 we have the fifth term as 32. Same goes over here. For an is equal to 2n minus 3, we have, for the first term we have minus 1 by 6, for the second term we have 1 by 6, the third term is 3 by 6, fourth term is 5 by 6, and fifth term is 7 by 6. The similar, by applying the similar ideology, the first 5 terms of any sequence can be found in the given exercises. Over here, we try to find the first 5 terms of the sequence for this particular scenario, where an is equal to an minus 1 by n, where a2 is equal to a1 by 2, that is minus half, a3 is equal to a2 by 3, that is minus 1 by 6, a4 is equal to a3 by 4, that is minus 1 by 24, and a5 is equal to a4 by 5, that is minus 1 by 120. Next, we try to find the number of terms between the two numbers a and b, including those numbers a and b. We came up with a plan explaining how it comes, such as we came up with a formula, and we also got to know how we can remember this formula. The number of terms between the two numbers is given as bigger number minus smaller number plus 1 when we need to include a and b. Over here, when we need to find the number of terms between the given two numbers a and b, in which we don't need to include a and b, The formula is given by b minus a minus 1. We can remember this entire formula because if we need to include the numbers, remember it's plus 1 not plus 2, that is bigger minus smaller plus 1, and when we need to exclude, remember the formula is bigger minus smaller minus 1. So exclude is negative, exclude is negative, include is positive. That's how we can remember this formula to find the number of terms between a and b. Next, we discussed how Carl Gauss came up with the plan and he found the sum of an arithmetic series, how he came up with the formula, and that's the entire summary. That is, we mean an arrangement of numbers in a definite order according to some particular sum rule. That's a sequence. We define a sequence as a function whose domain is a set of natural numbers or some subsets of the type 1, 2, 3 and k. A sequence containing a finite numbers of terms is called finite sequence. A sequence is called infinite if it is not a finite sequence. Also, if the sum is expressed of the given of the terms in a given sequence, it's called a series. A series is called finite series if it has got finite number of terms. For example, 1 plus 3 plus 5 plus 7 plus 9. If we have a sequence in which we have the terms as 1, 3, 5, 7 and 9, if we add all of them, we'll get a series called, and sum is going to be 25. So these are the ever applicable last minute tips to maximize the score, and you can learn from the India's top Cbse educators. You can use the referral code, and the course is going to be run for throughout the year. You can join the course on sequence and series starting from 13th of April from 4 p.m. We'll discuss arithmetic progression and governing topics, and then we'll discuss geometric progression and governing topics, and then harmonic progression and governing topics. That's all from my side. See you. And have a great day.